Alrighty. In this example, we are combining acetic acid and sodium hydroxide. And I gave you the formula for acetic acid. It is a compound formed with hydrogen and the acetate anion. So we can look at it as far as the way that it would work as an ionic compound. We're going to learn more about acids, and especially acid, and this is actually kind of acid-base chemistry in a future unit, a few units away. But in this case, it is also a double replacement reaction. So we're just going to treat it as such. Okay. So what I would do is maybe find from acetic acid what my cations and anions are. You'll notice acetic sounds like acetate, and this CH3CO2, that is our acetate ion. Okay, I think on our chart we have it written. So another way you could write this is HC2H3O2. Okay, and if you look, the acetate ion is C2H3O2 with a 1 negative charge, so maybe this whole chunk here has a 1 negative charge, and this chunk here has a 1 positive charge. We put them together, you should get this formula. Okay, we also have sodium hydroxide. We know sodium has a 1 plus charge because it's in group 1, and hydroxide, well, as an ion it does, hydroxide is one of our polyatomics. It is OH with a 1 negative. So we should have HC2H3O2 aqueous plus NaOH aqueous, and we want to see what it forms. Okay. So in this case, we need to make sure that we swap cations and anions appropriately. So we're going to take this H plus and put it with this OH minus. We're also going to take this Na plus and put it with the acetate. Okay, if you take H plus and OH minus and balance charges, you end up getting HOH. Okay, now this has 2 hydrogens and 1 oxygen, and really what this is water. So another way to write it is H2O. The way that you should write it in this case would be H2O. Okay. And then we're going to have sodium with the acetate ion. You swap them and drop them, you get NaC2H3O2. Okay. Now water, I know, is a pure substance. And if all of this is happening in water, then really I'm just not going to form water vapor or anything. I'm just going to form liquid water. Okay. I just need to look here to see what's going to happen to that sodium acetate. So since sodium's a group 1, I should be able to say that it is soluble, or this sodium acetate would be soluble. I can also look here at rule 2. It says all common acetates are soluble. So got a double whammy of this should dissolve, and so that means that sodium acetate would be aqueous. Okay. All right, we can check to make sure the equation is balanced. So we have 1, 2, 3, 4, 5 hydrogens, and we've got 1, 2, 3, 4, 5 hydrogens. We've got 2 carbons and 2 carbons. We've got 1, 2, 3 oxygens, and 1, 2, 3 oxygens, and 1 sodium on each side, so it is already balanced.